Flipped classroom number 15. Here we are sometime on Friday, Saturday, or Sunday doing a review for Tuesday's test. We reviewed a little on Thursday night on the flipped classroom. Then we also reviewed in class on Friday. And I thought you handled your problems intelligently and were able to gain extra points toward your test. Notice what we did on Friday, practice simplify problems, verify or show that's, and then we were into solve problems. So we're actually solving trigonometric equations tonight or today, whenever you're viewing this. I think we'll do 3 of them, and so let me set the timer so I don't overdo it on this portion. So if you would, please take that blue sheet, was it blue sheet of paper that I labored on and punched holes in, and we were writing down our review problems. If you could add it to that. If that's not available to you, go ahead and just take a piece of paper and begin writing down these review problems. So the first one is solve, and we're looking at solving 2 cosine 2x minus square root of 2 equals 0 on this interval between 0 and 2 pi, including 0, not including 2 pi. In order to solve this, we're going to get this part of the argument all by itself, and we do that by moving the square root of 2 over and dividing by this 2. Lots of 2's on this problem, and now you may be tempted to get rid of this 2, but you'll recall this is like a marriage inviolable, and the plan is to keep the marriage together, to keep the argument together, and we will be able to break up the 2 from the x after we take the cosine, but right now we may not do that. Alright, so now we just begin figuring out from our unit circle what this whole value has to be such that the cosine is square root of 2 over 2. So looking for the first value on your unit circle, going, oh yeah, that's right, because this is doubled, this is now going to be doubled. So we're not going to look in one circle. Because of this, we're going to change it and multiply. This is telling the reader what x is doing. So we have to double everything for 2x. So this doubles 0 and it doubles 2 pi. So we have doubled our fun, and we will look around the circle in going around twice. So when we look at our unit circle the first time, we see that pi over 4 is where the cosine is square root of 2 over 2. And again at 7 pi over 4. And I'll write that one on this down here. And if you recall, what we do with those is we go back to each one, and what I called it is we spin it. In other words, since we're allowed to go around the circle again, I'm going to add 2 pi to this. And that's the equivalent of going around one circle away from pi over 4. So 2 is 8/4, so 8/4 and 1/4 brings me up to 9/4 pi. And I check and see if that is in the permitted range, and 4 into 9 goes, what, 2 1/4? So we're still within the right range. So then I spin, so to speak, this one by adding 2 pi, and 7 pi over 4 plus 7 pi over 4 plus 2 pi. Again, this is 8 over 4. 8 and 7 give me 15 pi over 4. 4 into 15 is not greater than 4, so we're still within range. So I've spun this one and I've spun this one, so let me go and spin this one. If I add 2 pi to it, I'm adding 8/4 to 9/4, I get 17/4. So you can see that is greater than 4 pi, so it's out of range. So we ended up with pi over 4, 7 pi over 4, 9 pi over 4, and 15 pi over 4. Let me write those in one row so we can see clearly what's going on without all my spinning work. We have 2x equals pi over 4, 7 pi over 4. Then we went up to 9 pi over 4 and 15 pi over 4. Now that we have taken the cosine, you know you've taken the cosine if you've looked at your unit circle, and certainly we did to get these values. And so now you may break up this argument and divide everything by 2, because in the end, when the word solve is used, you want to know what x equals. So I'm dividing this by 2, this by 2, this by 2, and this by 2. Algebraically, 2 over 1, flip and multiply. You'll see these become pi over 8, 7 pi over 8, nine pi over 8, and 15 pi over 8. All right, so that's a good review of that, how it works when we have multiple angles. This is a double angle. Notice it revealed 4 answers. Often when it's tripled, you get 6, and quadrupled, you get 8 answers. All right. Let's see how you do on the next one. The next one is also a solve. The only difference being I want all answers. I'm not going to restrict it in any way, so I'm going to want all of them. We'll pause and see how far you can get on this one by yourself. So to solve this problem, we are going to write it down. It says sine squared x minus, 4 sine squared x minus 3 equals 0. And the command is solve. So at the end of the story, we want to know what x is. So we want to get x sine x by itself. Move the 3 over, divide by 4. And then you want to take the square root to undo the square of the sine. So that gives me sine x on the left, and plus or minus square root of 3 over 2, because the 4 is under the square root sign, but I remove it when I write it as a 2. So that's all we have to do algebraically. Now we look to our unit circle and we find the places where x is equal to plus or minus square root of 3 over 2. So I'm finding that at pi over 3, where else? Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Alright, so those are the values. So let's look and see how we can represent the infinitude of these if we spin this one, and this one forever. So I usually take a little sketch of it to help me decide on that. Is that showing up? Yep. So pi over 3 is right here, about there. 2 pi over 3 is here. 4 pi over 3 is here. And 5 pi over 3 is here. So remember how this works. We can take pi over 3 and generate the one that's right across from it by adding how many radians? Pi radians. So in order to add, so then we can add another pi and keep going around by half circles until we get them all. So we indicate that to our reader by the pi n. So pi over 3 plus pi n takes care of this one and all the ones that are spun off of that one and that one. So now we have to take care of this one. So I'm going to grab it 2 pi over 3. And I'll recall that to get the 5 pi over 3 is right across from it. So we can also just add half a circle, which is pi radians, an n number of times. So we'll keep generating all of those. So there's your answer for all solutions to this quadratic trigonometric equations, or equation. All right, let's go on and try to do one more. 6 seconds. I think I might try to smush this on so I have one video. All right, let's see if I can get it done or not. All right, this last one that I would like to do is solve, and it's going to be on this range that I'm going to look for the answers, and it's secant squared x minus secant x minus 2 equals 0. If you would pause for a moment, have a pause point, and factor that for me. You'll notice you can't remove a secant from all the terms because there isn't one there. So we have to factor it in the FOIL way, where the first times the first will give us this first. Then we have to think of a number that multiplies to give me -2, yet adds to give me -1. -2 plus 1 does give me the -1 secant. And now I set each of those equal to 0. Secant x equals 2 on the left, secant x equals -1 on the right. So now I'm not used to working in secant, I'm used to working in its reciprocal. So you need to know on the test what is the reciprocal of secant. So by now you should know, study if it doesn't come yet, flip this side, flip that side, and we get cosine x equals 1/2. So on that side, you go to your unit circle, and the places where cosine is 1/2 is pi over 3 and 5 pi over 3. And the places where, and this is flipped as well, so when you flip secant here, again you get cosine, and -1 over 1 when it flips is still -1. So that appears at pi radians. So I found a solution to this equation at these 3 places. All right, that's it for this weekend, and we'll have our final round of review in class on Monday, and we'll be ready for the test. I will explain on Monday clearly which trig IDs will be available to you. But you need to study, at least for now, the Pythagorean IDs, the reciprocal relationships for sure, and those deathbed ones. Sine over cosine is tangent, and cosine over sine is cotangent. Those I know will be required by memory. So, till Monday, hope your weekend is going well and that you take time to begin your studies. See you on Monday.